Last time we learned how to use abstractions in the form of the so-called interface to make our life a bit easier as programmers. It doesn't really affect the program itself, the stuff the computer does, but it helps us write our code a bit more efficiently. And today we're gonna look at something similar, but different in some very important aspects. To start with, let me give you another example again. Start with not writing because I'm not in the... Now we can write. It shows up on the stream? It shows up the stream, good. Starting with one class player, which is just gonna have some help. Right. A typo. And our player will have to fight enemies. And that might be, for example, the very classic slime, which will have a method that can attack a player. Why does it not? What happened? What happened? There we go. Something with my keyboard switched. Alright. And all it's gonna do is player dot health is reduced by 1. Let's make it very simple. Let's not assume something like lowest health, and let's not deal with the follow-up on that. As always, we're just gonna keep it very simple. And maybe we have a dragon, something bigger, which will also be able to attack a player. But... right? Well, maybe the dragon should have a bit more on attack. Let's say one attack from a dragon is 10 health. But the point still stands. Stands? Stands. We have two enemies, a slime and a dragon, which both can attack a player and reduce their health. Alright? And something we learned last time is we could create an interface. It's just enemy, and they have a method called attack, which receives a player. And then we could mark both our slime and our dragon as enemy. And now in my code, I could just use enemy everywhere to use both slimes and dragons and any other mob we add to our game. Something I did not address with that, however, is I still have to write this code. I mean, it makes sense. I just told the system, or the compiler, I want to make sure that everything that is flagged as enemy has a method called attack. Which, yeah, that works. We run the code. It didn't output anything, but it compiled, everything's fine. And I can... enemy, slime. Can use the slime, and let's read the player first. Player equals new player. Like that. And now I can use enemy dot attack player. And maybe let's change this code a bit. Let's add a constructor in here. Let's be a bit fancy today. The default constructor will start with a health of 100. Okay, and let's maybe console.9 health plus player.health. Let's output this now. Started with 100, went to 99, and let's switch this out with a dragon. So our code worked, our player got hit, and we didn't have to change anything in here except for it's a dragon now. And of course, we have now an easy way to store different creatures by using array, which we can use simplified version, slime, or new dragon. And regardless of what it is, we can just store it in this array. And we could use anything in this array to attack the player. Right? That's the advantage we have using the interfaces. But for every single enemy, I still have to write out the code to attack the player itself. We only told the system to ensure the signature, but we never told it anything about the content in there. And while for some situations that's perfectly fine, I mean, there's a reason these are different classes, because they behave differently. There are also things that are very common in between. Like if you look at the code, the only thing that changed is this number. And now imagine that this is not as simple and I have to actually do a lot of additional processing in here, like status effects or special conditions for players' health, and I will probably involve certain features of the player itself, which we haven't written. There's gonna be a lot of code that's necessary to handle the attack. That's gonna be very similar in both a dragon and a slime. And only the actual values will fluctuate a bit. Maybe some additional stuff, but usually most of the code will look very similar. And programmers are lazy, so of course there's a way to simplify this. And the way we do that is by not writing a new class for every enemy and then just labeling it as an enemy, but to write a single class for every enemy, which is then extended for different specifics for different subtypes. Now let's roll back on that. Let's start with the first part, just the general. Actually, let's use this thing instead. Let's just write a very general class for attacking players, an enemy class, which attacks the player and then can reduce the player health by 1 for now. Right, so we have a class called enemy, which just reduces the player's health. And this class could not be used as the basis for further classes, for further types of enemies. We could just decide that, no, let's make it simple. Attack power is just a value it can store, and then we have public enemy attack power and the constructor, and then we set attack power to that value. Yeah. Can type. So let's drop this for now, since we don't have the interface anymore. And we're dropping this. And our enemy is going to be new enemy, just like that. And we give it an attack power of 1 if we want a slime. What did I forget? Oh. Forgot the accessor. My bad. Like that. This would be the slime, and this would be the dragon, and we used the same class. I only wrote the code once, but I can use it for dragons or slimes. The difference is just one number. And I could include a string maybe in here to determine what the name of this type of enemy is, which might be the name dragon or slime. But what if they are special behavior? Let's say, well, that was too far. Let's say a slime can just attack. just generic attack. But let's say a dragon has special fire breath attack, which inflicts additional fire damage. Basic attack would be just swiping its claws, maybe, but there's a more advanced attack that a dragon can do that affects the player in a different way. Let's say it's also stronger, just for the sake of it. Our enemy class only has the basic attack, just a very generic I can attack and do some damage. To extend this, we would either need to write a completely new class like this, or we would have to add a lot of additional methods in here that would take care of a lot of very generic behavior that an enemy might have or might not have. But that means we would have additional methods for something simple as a slime, which doesn't need it, and maybe not specific enough for something like a dragon, which does need it. And so we can instead decide to use these additional classes that we have, the slime and the dragon, to extend the code that we've written here. That works by taking our class, and we did the same as we did with the interfaces. We add this back again, but you notice how I left everything out in here. Think of it like taking this code and just extending it with this code. Like, that's the very rough, incorrect version for now. So this is as if we just extended the enemy with nothing for the slime, and same for the dragon. We just took this code and wrote some additional stuff, or in this case nothing, and that's that. So all we did is say take the class enemy, standalone class that worked, that we could use, that we have already used in the code, and extend it with, well, nothing for now. But once you've extended it, call it slime or dragon. No difference for now. And I can now use slime. Well, actually I can't use slime directly. That's the first issue. See, I defined an enemy as something that has to be constructed using an integer as attack power. And while I say the slime extends the code, it is still its own class. We use the keyword class. So while this is a class, this is also a class. And the computer still expects us to do some of the basics of every class, like offering a constructor. And if we don't do that, if we write a class without a constructor, if you remember, it will just add a default constructor, this one, which doesn't receive any values and doesn't do anything, and that's that. But to make the enemy work, we need a constructor. So in order to extend the class enemy as a slime, we have to offer a constructor as a slime that can satisfy the conditions for a constructor for enemy. And that can still mean we can just make a public slime, a default constructor that doesn't do anything. We write it out specifically, like that. But we have to tell the system that it should still use the constructor of enemy, the class we're extending. By the way, extending is not the official word, I'm just using it for now because I feel like it's easier to understand what we're doing. And that is done similar to how we did this. And with interfaces. Remember, we had the definition for our class, and then we used a colon to signify that, hey, we're adding some additional info for this class. And for interfaces, that was just the name of the interface, to tell the system, hey, we are using the methods defined in that interface. We're implementing this interface. And when we're using the system here, where we're extending a class, we also have to just add the class we're extending. And inside our code, we use the colon again to tell the compiler that we're doing something more with this constructor here. There's something special going on. It has to add some other code. It has to bring in some other code that is affected by this or connected to this. And now it gets a bit weird. There are two keywords we haven't discussed before. One that we could have discussed and the other that's becoming important now. We want the slime to extend the code that was already written in enemy. We want to use this code that was written for the generic class enemy, and we want to extend this code to be a slime specifically. So slime is a class that is based on the class enemy. This class is now code that's fundamentally dependent on this code up here. This is the baseline code that both Dragon and Slime are going to be using. It's a foundation. And to refer to that, we use the keyword base. There's another keyword we can use called this. If we use this, we mean we refer to the class you're currently in. Which sounds weird maybe for you, because we are in the class itself. Why do we need to refer to ourselves? There are reasons. We'll get to them. Maybe not today, but some other time. Just know there's another keyword specifically to refer to ourselves. But important for us now is the keyword base, which refers to the class we are based on. So if we have a constructor for slime that's using base, it means it's referring to this class up here, enemy. And what we're doing is we're calling the constructor with this. So instead of saying this is extending the constructor for enemy, like this, we're using the more generic base, which is always applicable. You don't need to specify what the base class is, since you've already set so up here. That would be redundant to write it in here as well. So base is the keyword, and then we are having these brackets, which are just calling the constructor. That's a bit weird about this. While up here, up to there, it's just the signature for a method, in this case specifically for a constructor. The stuff after the semicolon is actually executable code. It's like a single method call, a single constructor call to a specific constructor in the base class, enemy. That part might take a bit to sink in, because there are some weird things you can do because this is executed as code, as almost procedural code. You can actually call other methods in here and make additions and have operations and instructions and whatnot. You can do a lot of stuff in here because it's executed as code, even though it's part of the signature for a constructor, which is just definition and not code itself. It's this weird crossover between two worlds. But for us, all that matters is we can pass a 1 into here, as if we called the constructor for enemy with a 1. We basically did this, just down here. And we have to do the same, of course, in Dragon. Public Dragon. Got the brackets. It's also going for base. But in this case, we want a bit more damage, so we call it with 10. So we have a dragon that's calling the base constructor with a value of 10, and slime, which is calling the base constructor with a 1. So this code can be changed. We don't have to add the values anymore. Slime doesn't have a constructor with an argument. There's no constructor in slime. There's a constructor in base, but we are calling slime specifically. We're not saying enemy up here, which would expect us to do something like this. Oh, I forgot, where did I... It's there, it's... Oh. Why do I have two here? Let's do it like this. So, this would be fine if I call enemy, but we're using slime specifically. Slime doesn't have one. But this way, a slime is just an enemy that reduces the health by 1. And I can use dragon again. And it reduces the health by 10. All by just simply defining that slime is an enemy, a generic enemy, with a specific damage of 1. And a dragon is a generic enemy with a damage of 10. I only had to write down these definitions once, and all the code for actually damaging the player and handling that is done up here, in our enemy class. I only have to write that once, including all the other effects it might have. But because these are extending the function of enemy, I can also add our breath attack again. What did I call that earlier? Breathe fire? It's up in caps lock? Caps lock. Breathe fire. Ooh, player. Yeah, like that. So I could just do player.health and here. And spread that out. Let's just keep it at that for now and demonstrate. So enemy is a drag, normal attack, that's fine. But I can also just call this a dragon, which still works. Same. But now I can also do breathe fire, because it's a dragon. Now we have 30 damage. Swipe with a claw and fire breath. If I called this enemy, of course, it's just as with the interfaces, I couldn't do it anymore. Because enemy, just the class enemy, doesn't have any definition for a method called breathe fire. Just the same as with interfaces. This enemy could be anything, in theory. So the computer doesn't let us use special methods. But it's there. We can specifically cast enemy to dragon, because we know enemy is actually a dragon underneath. So we're casting it to dragon again, and then we can use breathe fire. Same as with interfaces. Not so different. And now you can clearly see what I meant with extending. A dragon has all the methods and all the fields. Oh, maybe I should mention that too. The fields are available as well, of course. For example, I could do this and increase an enemy's attack power by 2. Give him a buff. Because I have access to that field that was defined in enemy. Even though I'm a dragon, I have an attack power. I have a method called attack. And I don't automatically have the constructor, because constructors are specific to the class. The constructor can only handle the class itself. Which makes a lot of sense if you think about it this way. Let's say dragon has a strength for its fire. What happens? Well, like that. Right, so same logic as before. We can still execute the code. We can't execute the code. What did I do wrong? Wait, what is going on? Did I mistype? Oh. Okay, it was a typo. Right, so the dragon has a specific variable, specific field to contain the amount of damage its fire breath can do, but it also has the attack power. Now imagine if we just called the constructor for enemy when we try to create a dragon. That constructor up here, an enemy, doesn't know what a dragon is. A dragon knows what an enemy is, because we are based on it, but enemy itself could be anything. Could be an enemy just generically, or it could be a slime that's secretly an enemy, or it could be a dragon that's an enemy. So this constructor has no idea what fire strength is. So this constructor would not be able to set up the field fire strength. That's why you cannot use the constructor of the base class, the one you're extending, the one you're basing your code on, to create the higher level, or not higher level, the class in a higher position in the hierarchy. So dragon extends from enemy. So it knows everything about enemy and can use its methods and fields and whatnot, but enemy doesn't know the other way around what a dragon is and cannot use its methods and fields. So when you create a dragon, you still need to use a constructor specific to dragon. And that constructor then can pass on values to the constructor of the base method, base class, if needed. Does that make sense? I hope it does. Maybe let's do a simple illustration. I prepared something, I hope it works. So that's where you have the base class. That should be about here. No, doesn't work. Doesn't work. Come on, technology. There we go. The stream did not end. Sorry. That was kind of weird. Why is it switching around so much? That's unpleasant. Right. Let's try again. So we have the base class. Okay, this is gonna be not good. Why is it? I'm having to improvise right now because the tablet still isn't working. Let's try again further to the right. Should be here. So, and I cannot draw. I'm using a pen tablet right now, but I'm not used to pen tablets. So I have to use the screen to see what I'm doing, but I have to move my cursor or my pen down in front of me where I don't see it. People who are used to it, you are amazing. I have no idea how you do that. Anyway, this was enemy. I'm just gonna give it an uppercase E, which looks bad. Let's make it a bit nicer. That's enemy. Actually, no, let's put it differently. We have the field, let's call it P for attack power, and we have the attack method, and this is E for enemy. And then we have this extension. That's for the fire breath method. And then this whole thing is the dragon. Okay. Illustration would be easier if I could draw properly. You have to do with this for now. So we have the base code for enemy. That is one full class, fully working. And we have dragon, which is also a fully legitimate class that is working. It's just that part of the code for dragon is coming from a different class, has been written in enemy. And so we could also... Why does this draw lines? Seriously, it's drawing lines, why? Oh, weird. Whatever. We could also extend it to do nothing, and then that would be slime. No, skipping over the part for the dragon. So this part up here, this is universal. Both dragon and slime have this code that I wrote once. Dragon has some extra code that is only specific to dragon. And slimes could have some other code as well, specific to slimes. So when I go in here and go back to the slime, public void resolve. Like a slime does. Dot. Maybe does some more damage. But yeah, that's a specific method to slime then. Dragons can breathe fire, slimes can dissolve. Both have basic attacks that everyone can use, which only has to be handled once. And because it's a basic method that everyone can use, we can actually reuse that in here by calling this method. We can do it like this. We can attack a player. So it will behave exactly the same as a normal attack. So we might extend this class a bit to include the damage. Instead of reducing the attack by attack power, reduce it by damage. But this is a bit weird now, because once I extended this, let's do it here as well. Attack player 5. What? This method works perfectly fine for slimes and dragons, but the enemy class in general is slightly different from what it's supposed to be. Attack now requires me to actually input a damage value. Which, okay, is fine, but it kind of defeats the whole point of having extra classes where these values are predetermined. I mean, we're not even using this field attack power anymore. I would have to use, if I want to use that still, actually request that value myself and pass it on. Kind of redundant. So why not make this method private? So we don't see it on the outside anymore and don't have to worry about providing attack power. And instead we add a second method, which is public, which we call attack, but this one gets just the player, and internally we call the other method that does the damage calculations, pass it on like that. So if we call enemy.attack from the outside, where we can see only the attack method with one argument, just the player, it will internally just figure out what the default attack power of our enemy is, which is stored on the field, which is provided in most cases by the constructors for dragons or slimes, or by the constructor itself if it's a more generic custom enemy. And it will then call the actual damage code and the internally hidden attack method. But this creates a new issue. Remember what the private keyword does? Well, to recap, public just means everyone can see this. Everyone can see this class enemy and the field attack power and this constructor and this method attack. Private means only this class can see this method. Only enemy has access to this specific version of attack. That also means that Slime and Dragon don't get to see it. Dragon is not the class enemy, it is an extension of enemy, it is a kind of enemy, but it's not the base class enemy directly. That's a very important distinction. Dragon is not enemy, Dragon is a enemy, it's not enemy. Same with Slime. So if I were to try to compile this, the compiler will complain. It's inaccessible to its protection level. We're trying to use the attack method, which uses two parameters, two arguments, but that one is hidden. We are not allowed to use that. Enemy has control over that method, and enemy decided, nope, this method is private, no one gets to use it except for me. Which is a problem if we want to use that method for other types of enemies. So we want to loosen up the restriction a little bit. We don't want to use the public accessor because we don't want anyone outside of an enemy using the wrong attack by accident, or not so accidentally. But we also want to give it up for use for other classes that might be extensions of enemy, that might base their code on enemy. And that's where we have another accessibility level, protected. Protected is less private, but also not public. It's in between. Protected means I can see it, the class itself, and every class that is basing their code on mine. So every class that is based on enemy can now access this method. So this code will work just fine. If I were to try to use this method on the outside, however, in just the class program, which doesn't have anything to do with enemy, would get, again, an accessibility error, because we are not allowed to use this method. So that's how you can use protected to extend the idea of private to other classes that extend your code. And I'm calling it extend the whole time. This concept is called inheritance. And we're touching upon a topic called polymorphism. Or, actually, I'm not sure what the English... That should be the English term, right? Sorry. It has been a while since I officially learned this stuff, like in a formal environment. And that was unfortunately mostly German. So a lot of terms are not known to me. But that's the base idea. We have base class, and sometimes these are also called parent classes. And these are the child classes. They inherit from this other class. That's the idea. Parent, because they give up something of their own to their children, which inherit those traits, for example. Or in this case, method and fields. So now we have this special class enemy that can be used on its own, but we also have simplifications in the form of very specific enemies where we already predefined something like the attack strength. We don't have to worry about that. But they also offer some individual traits, something unique to them, something only slimes or dragons can do. Does it make sense to keep enemy around still? Right now, remember, I can create a new enemy, just give it some damage, like 100, and that should work. It doesn't make sense. Maybe. There could be a reason why you want that, but often you only wanted some way to avoid writing this code several times, which has a couple of reasons. But we didn't really want the enemy class itself to exist for use. It's just to make sharing code between two classes easier. So what we can do is we can prevent someone from creating a new enemy. We could, for example, change the accessor here for our constructor for enemy to protected. Keep in mind that protected means only we or the children can use this. And the children do use the constructor using the base keyword. But we're not up here in the program, we're not in enemy or one of the children, so this does not work. So let's change this to dragon again. Dragon can still use the constructor. The dragon still sees it and has access to it. We could also make it private. Doesn't make much sense in our case, but there are reasons why you want to do that. And of course, in this case, dragons and slimes couldn't create new instances anymore because they rely on this constructor. So protected seems like a good choice for now. There's, however, another way we can do this. Actually, not another way, it's more like a more intentional way to hide this class into the obscure background of our code. We can mark it as abstract. Another keyword you have to learn. And if I compile this now, nothing changed. The code behaves exactly the same as before. The important bit is, if I were to try to add maybe another constructor in here. Let's say we have a second constructor, because, oh, maybe I do want a generic enemy with just, like for testing purposes, maybe someone added a constructor with an enemy with 0 damage, right? Just for debugging. They made their lives a bit simple. Now we have a new constructor. Well, if I didn't have this abstract, no problem. And we can actually use enemy now. But if we specifically add this keyword abstract, oops, I can write, come on, there we go, abstract. What this does is cause an issue for the one who tried to sneak in this public constructor. If you mark it as abstract, this class will be enforced by the compiler to not be created directly. You can still write code in here, just fine. You can even create constructors, as long as you keep them protected, hidden from the outside. The only ones who are allowed to use this code in here directly or create the infrastructure for this code to work, which means creating or filling these fields, are the classes that directly inherit from that base class. For us, Slime and Dragon. Only Slime and Dragon are allowed to use that code. And only Slime and Dragon are instances of an enemy that can be created. There is no other version of enemy anymore. So this way, you can, for one, protect your code from accidental changes that are not intended. But it also makes it very clear what this class actually is. It's abstract because it's not a real class, it's not something you actively use. This is just a container for some generic code that is shared between some other classes, which goes beyond just they have this method and actually includes code. Now at this point I should mention that Up to C# 7.3, this was the only way you could share the code, because interfaces only allow you to define the signature. Newer C# versions, however, also allow you to actually write out code in an interface, which gives them a default code that will be used by inheriting or by implementing classes if they don't provide it themselves. Which is a pretty cool feature, but it only exists in newer C# language versions. And if using something like .NET Framework, because you're forced to due to circumstances, you don't have access to that. So just a heads up, if using .NET Framework, or I'm not sure how far Mono is. Maybe an older version of Monos doesn't have it. I would assume that newer versions do. But also .NET Standard, for example, 2.0, also very widespread still. In that case, you don't have access to that feature, and this is the only way for you to share actual code between different classes in an elegant way. I mean, you can always write code, generic attacker code, that handles just this part in here, in this attack method, and you pass on a generic instance of that attacker code to your different enemy types. I mean, that's another way, right? Now, abstract, as that means that this code is not to be executed or not to be used directly. You can create an enemy and use it. That means we have an advantage for creating new methods. We can, for example, sneak in a method called public void spawn. Right? Just some generic method that's called when the monster is first put into a level to do something, I don't know what. Maybe to make a sound or to have some sprites wander around, make a little animation, do whatever. We want to make sure that every enemy has this spawn method, just like an interface would do that. But the code is so different for every single monster type, and maybe they don't use it at all, that it doesn't make sense to predefine code in here. We can't anticipate that. So instead, we're pretending that this is an interface, kind of. Of course, if we write this in a normal class, we would a complaint. I'm not clicking run right now because I'm afraid it will spoil it. Actually, what the hell, just spoil it. This error message tells us all that is to know about that. We're an abstract class. The compiler already knows that this thing doesn't need to be created in one go. This doesn't need to be a fully functional, valid method. We can get away with a few things, like not actually giving the compiler code for a method. We just have to add the little marker, abstract again, just to tell it that, yeah, we do want a method called spawn for enemies, but we don't have any code here to do it. Just enforce the method to exist for everyone that inherits from enemy. So just like an interface, we have not the case where we have to write out the method in our classes, because otherwise we will get a complaint. I shouldn't have clicked on that yet. Okay, another spoiler. There's an issue with inheritance we haven't discussed so far. I guess we'll spoil it like this. This is what I actually wanted to see. Anyway, if we don't put the method in, we get a complaint from the compiler, just as we would with interfaces. We don't have to add actual code, we just have to make sure the class exists. Yeah, the method exists. Now if I compile this, what did I forget? Oh, I left that code in here. Sure. Okay, let's try again. That looks better. Now, the thing that got spoiled is this keyword. Because let's say the standard attack is too standard. What if even the standard attack we have here needs to be changed slightly for a slime because of the specific way it works? Like a dragon might just do a normal attack, but a slime cannot directly attack, maybe. So what we have to do is allow a slime to change the behavior of the very basic attack somehow. But how would you do that? If anyone called slime.attack, well, they will call this generic method attack, which will call this internal method, this protected hidden method attack. We don't really have control over that. It's all code up here in enemy. We can, however, define enemy as something that can be overridden. That's what the keyword is for. If we... let's keep that part for now. We can write our own method in here. Public... Oh no, not public. Let's... Actually, I'm lazy. Let's just copy paste it. Like that. If we take the method and write our own code, what could be so special about that that couldn't be done with damage? Okay, let's be weird about it. So, because damage is an integer, it will first divide by 4, lose the decimals, and then multiply by 4. Basically, what we are doing here is just forcing damage to be a multiple of 4. So a 5 damage would still be just 4. 7 damage would still be 4. 8 damage would be 8 damage. I'm not sure why that's gonna be so weird, but it's an example of a weird damage calculation. But now we have an attack method down here, and an identical signature, at least, attack method up here. And that's an issue, because now the compiler has to decide which attack method will be called when we call attack. Now you might think, attack, the original attack method here, is calling this code up here, which, yeah, it does. And this will now call the method attack with 2 arguments, which is also defined up here. But now it's defined a second time here. And that's where the compiler starts going from top to bottom. We start at the topmost class, slime, and try to look for a matching method when we call it. And if we can't find it in slime, only then will it go down a level to the base class and try to look for a method in here. That already happens with this attack. If we call it enemy.attack, then it will first try to find a method called attack in slime, anywhere in here. Because there is no method called attack within slime, not an attack method that is public and has only 1 argument. Will then jump to the next class in the chain, further down, enemy. And we'll look in here and it will find a method attack that is publicly visible and only requires a player. So it will execute this code. Then down here it will execute another attack method. One that's visible from an enemy and receives 2 arguments. But again, because we are a slime at that point, we will start looking at slime. The code is written in enemy, but looking for a method always starts in the topmost class. That is slime. So if we look at our notes, what we're doing is we always... I have to change windows. You can see it, but I can't see it. Like that. Okay. So when we look for method, we always go from bottom to the top. It's down here. I think there's more space in here. I can't draw like this. I can really not draw like this. Okay, come on. I can't. Oh well, better than nothing. We're looking for methods. It's always going from top to bottom. Oh, actually, this is bottoms up. The way I drew it. Oh well, whatever. We're always starting at the class we're starting in. Look for methods in here. And then we go further up in the top and try to look for methods in here. Every single method call is working that way. So when we call attack on a slime, the second attack method will actually be this one down here, because yes, we do have a slime method called attack, which receives 2 arguments. So the compiler will not, or the computer actually at runtime, will not look for further methods in enemy. There is one, but the computer doesn't even check, doesn't care. We have a method, we execute this code. Now in theory that's enough. In practice, however, this might be a mistake. We might just have made a mistake in programming. So we have to let the compiler know that this was intentional. We wanted this to happen. And that's what the keyword override is for. We let the compiler know that yes, we are aware that this is a method that already exists in the base class, and that we intentionally create a new version of that. You might argue that for spawn, that's kind of ridiculous because we have to make it. There is no not writing the method, but we'll let that slide for now. That's just a weird quirk. And if nothing else, it tells the programmer that's reading this class that, oh, this method exists in the base class. And they might decide to check that out and see, oh, it's abstract. But regardless, they know spawn is not unique to slime, at least. That's useful information. For this other method, lets the compiler know that we are fine with this attack method overriding the behavior of the base class attack method. But besides overriding it down here, we also have to make that clear up here as well. Basically, the child and the parent have to agree that this is okay. This works in both ways. And to do that, we have to mark this class with a specific keyword as well. We have to let the compiler know that child classes are allowed to override the behavior of this method. It will not mess with the logic in a dangerous way. It's intended for them to override it even. They don't have to, we have code in here, but we let them do that. And where in the base class where we override the method, we have the override keyword. In the base class where we defined the method, we have to call it virtual. Which is a weird keyword choice. I'm not sure why they did that, but anyway. Virtual means that this method isn't set in stone, is the best way I can put it. It exists, but it's more flimsy. You can't just replace it with something else. This is just a virtual just means it's a default version of the method you can override if you need to. Abstract just means you have to do the method. I'm just telling you it has to exist. I'm not giving you any default code. Virtual means you can override it, or you can use the default code I have in here. And by the way, you can write virtual methods that don't do anything. Just a side note, sometimes quite useful. But yeah, you can have virtual method that can be overridden by a child. And whenever you call the method on the child, it will prefer the child version over the parent version. Let's try to see that in action. I have a slime. And let's up the damage maybe a bit. Let's say slime does 5 damage. It will actually only do 4 damage, multiple of 4. So it did use the new method that we wrote in slime. Let's do something different. What if we actually no, let's not do that. Let's not do that. Instead, yeah. Let's skip that part. Let's get to the next question. If there's a lot of code in here in attack, and you didn't want to replace it entirely, what could we do then? My little change here that changes the base damage value, well, that's only the integer value that we got in, slightly modified, but the rest of the code is identical. So what if we want to reuse this code as well? Well, first, actually let's damage, let's 4 that. Let's first change damage like that. So now this code down here is the same as up here. And what we can do is we call attack again. Almost like a recursion. Well, in fact, right now this is a recursion, which would be a problem. Stack Overflow, because we never stepped off of the recursion, if you remember that episode. What we wanted is to actually call this version of the attack method, the base version, an enemy. And we can get to that by using the keyword base again. So we just write any method, it will first look in slime. But if you use the keyword base, it will automatically jump to one step down, to enemy in this case, and start looking for the method in there. It will ignore any method called attack in slime itself. So if I call it now, it's still doing the weird only multiples of 4, but the actual attack code is only up here still. Of course, doing this is a bit weird since we defined the base damage ourselves. It's constant, there's no multiplier, but you get the gist. Alright, so that's inheritance and abstract classes. Let's talk about some further notable things to look out for with inheritance. First of all, static. You remember that you can define a class as static, right? Do it like this. Static just means we can create instances of the class. It only exists once in our program, somewhere in memory, and everything you do is focused on that one thing in memory. Well, that's a bit of an issue. Slime extends enemy, and Dragon extends enemy. They're both based on the code of enemy, and enemy itself is suddenly marked as, okay, I'm just one single thing in memory. I can't be created multiple times with different values. I can have multiple copies of myself. while slime and dragon absolutely can. So that's a conflict, doesn't work. Further, let's say we have static method raw. Yeah, something like that. No, I don't want to save. So let's say this. It's a little issue. We could do that before if this was a normal class, but can do it like this. So, okay, that's fine. But this raw isn't inherited to slime or to dragon. The static again means it exists once through the entire runtime. If I were to slime and slime, let's store it specifically as a slime this time. That's rhyme. Yeah, okay, this will still not quite work. Okay, this still will not quite work. You can try slime with the class name, just as we did with the enemy. Then it will work. That is weird, I remember that wrong. What did I get wrong? Okay, I messed up. You want to disregard my rant on static? We'll skip to the next one. Seriously, I've written down something with static inheritance that was messed up, and I can't remember it well. I'm not at my best today. Honestly, I feel like I should redo the lesson. This code is a bit disorganized. Should have probably tried this after we switched to proper IDE where you have more syntax highlighting. Anyway. The settings. Ah, right. Next part. Let's for now return this to... Actually, let's keep it, doesn't matter. Public class. Let's call it NPC. Our NPC is gonna be the base class. No, the base class. Everything except for the player is gonna be an NPC. Alright, so an NPC will have public string. Let's just give him some name. Public NPC string name equals name, like that. And that means we should probably mark our enemy as NPC as well, right? Just like with interfaces. And Dragon, also NPC. Well, not quite. C# doesn't allow us to use multiple parent classes. It's perfectly fine to do so with interfaces. You can have multiple interfaces that you inherit from, and those interfaces can all look exactly the same. They can all offer the exact same signatures for method you require. No problem whatsoever. But inheritance forces you to have a family tree. You always can only inherit from one base class. But you can have multiple children. So every base class, like enemy, can have multiple children, or none. In this case we have 2, Dragon and Slime. So the tree splits off in 2. But if you go further up, from every class you can only have one base class. Exactly one. Never more. Only less. So NPC cannot be a second class that we inherit from. We would have to make this NPC as well. Enemy is an NPC. That will work. And we can skip that in here because dragon and slime are enemies, and enemies are automatically NPCs. That sounds weird. Anyway, the same rules still apply. Only now we have to include the base constructor that we did here for slime and dragon in enemy as well. Because NPCs require a name. So we have to do the base in here as well. Let's just generic name. To do name later. Like that. As you can see, base. We don't use enemy down here because it's clear what we mean with base, and we don't use NPC here because it's clear what we mean. We're referring to the next base class NPC. And now we can actually extend the raw static. We can turn it into a proper instance method. Plus name. Like that. So don't want to save, thank you. Let's put it like this. And NPCs can output their name. But slimes and dragons suddenly don't have the way to name themselves anymore. They could decide their own power because of the constructor, but not their name, because that is already predetermined by the base constructor in here. So to do that, we would probably have a second constructor, attack power, name, and it's passing on what we give as argument for our constructor, for enemy, name, to the base. So this is the same constructor call as this one, the base constructor, only we didn't provide the value directly, but we reused a variable that was available through the constructor. Again, this thing is behaving like code, like a method call. So you can actually have operations and instructions and variables, which exists at this point, because it's more like code that's executed in here. Just as we can call the base.attack method, we can also call the base constructor. It's just written in a different position. And we can still provide the attack power directly in here, and that's fine. But now this code is written twice, and that's... don't like that. So instead, we're switching this constructor. We're gonna leave that in because it's useful. We're switching this up, however, to not call the base directly, but to just use the attack power we already have and pass it onto this other constructor, as well as this very generic name as name. And that's where the other keyword, the counterpart to base, comes in. It is called this. And this refers to itself. So what we can do is pass on the variable for the first argument and this constant string for the second, and it will just call itself, its own constructor. Base refers to the constructor of the base class. This refers to the constructor of my class. So if I call enemy without any value, it will just use the generic name. And setting the attack power is still just written out once. But by offering this constructor now, I can extend slime and dragon. Okay, keywords, I forgot. This string name. So I can still leave the base damage a constant in the class, but I can pass on the name. And same here, I can just leave everything as is. I can actually skip adding a default name because the base class already has a version of the constructor that only needs an integer value. So I don't need to change this to this and provide default value. I could. I don't have to. So in here, same. String name. Name. I know this code is twice in here. That's a bit annoying. Well, not much we can do about that. Except when we start to add another hidden constructor that actually combines both these aspects and does a lot of foo, but let's ignore that. Let's just make it very simple and say a dragon cannot be created without providing a name. Because dragons are important, they all have a name. Every dragon has a very important name. Slimes, they don't have names normally, unless you name your slime. So now we have a slime with a very generic name. But if I try to create a dragon, I can't because I have to give it a name. Like that. Of course, I can also call the slime. Like that. With a name. And that works. And so I can chain inheritance on top of each other. Just like I could chain interfaces on top of each other. By building an inheritance tree. And the same rules still apply. All the methods in the fields in NPC are available down here in Slime and Dragon. They're just a bit trickier to get to them. Yeah, that's multiple inheritance. Or, well, the lack of multiple inheritance. Multiple inheritance in sense of multiple levels of inheritance. We have a large tree. And oh my god. Headache is getting worse. I should stop for today. Not my best episode to date. Not the worst though. Not the worst. I think with this we should only do one more episode on covering some small tidbits that I've left out over the last few weeks. Clean everything up nicely, and then it's time to leave the introduction to programming and get to something more advanced. Homework for today. There's no homework. Enjoy the rest of the weekend. Have a lovely week. Maybe practice a bit with inheritance. And I'll see you next time.